A.
F, E, B, C, D.
E, C, F, C.
You get out.
Did anybody not get those?
Everyone got it.
Does anybody have questions about it?
No.
Okay. All right, let's go down to the bottom part because I saw you guys struggling on the bottom part. So this is kind of a recap of Unit 1, but also some of the stuff that we did last class. Okay, so for this one, it wants to know what the increasing and decreasing intervals are. Okay, so this piece right here, from here to here, is this increasing or decreasing?
Decreasing.
Decreasing. And then what about this piece?
Increasing.
Increasing. And then this piece?
Decreasing.
Okay, and when we list the intervals of increasing and decreasing, what do we always list? What values?
The X.
The X values. Okay, so where does this graph start decreasing on the X-axis?
Negative.
Negative what? Negative infinity. And where does it stop decreasing? What X value does it stop decreasing at?
2.
Negative.
Negative 2, right?
And do we like?
Always parentheses when we're talking about intervals.
Oh shit.
Okay. So where does it start increasing then? What X value?
Negative.
Negative 2
Zero.
to 0. And then where does it start decreasing again?
0 to positive.
To a positive infinity. Very good. Everybody okay with that? And remember, how do we connect these two intervals? What do we do? The union, right? All right. What is the degree? What is the possible degree of this?
2.
No, 3. There's 3.
Okay. So remember last time we talked about if there's the degree is 4, then the turning points are 1 less than that. But we're going the opposite way. So how many turning points does this have? 2. So then what would the possible degree be?
1.
3, right? We're going up. So 3.
That's cheap.
What? That make no sense.
Okay, what about the leading coefficient? Now, I haven't given you the equation, but you should be able to tell me the leading coefficient by looking at this graph and looking at the end behavior. Okay, the end behavior on this graph over here, this is going to, as x approaches negative infinity, it's going up to positive. Okay, and over on the right-hand side, as x approaches positive infinity, y is going to negative infinity. So the leading coefficient will be positive or negative? Okay. So we know that the degree is to the third, right? Okay, so let's put that in the calculator and see what that looks like. So we know that this has to be something x to the third. Okay, so put that in your calculator. Y equals x to the third. To find the leading coefficient, you just want to look at the end behavior.
It's this way.
So is the end behavior of x to the third the same as this end behavior?
No.
No?
It's negative.
Okay, so try negative x to the third. See what that looks like.
No. Kind of, yeah. It does not. I don't see.
Okay, as x approaches negative infinity, okay, where is y approaching? Positive infinity. As x approaches negative infinity, where's y approaching? Positive infinity, right? As x approaches positive infinity, where's x going? Negative infinity. As x approaches positive infinity, where is y going? Negative infinity. So it has the same end behavior, which means the leading coefficient has to be negative. Okay? All right, what about the domain for this?
Negative infinity.
Negative infinity to positive infinity?
How do you spell that?
What about the range? Careful, remember down to up. So if I'm starting down here,
Positive infinity to
wait, what's down here?
negative infinity to
Negative infinity, positive infinity. Because remember that this is going down. This is going to go down. There's no starting point for this, so this is also going to go from negative infinity to positive infinity. No. The same. In behavior, yes, but this is different. This is domain and range. Okay, let's look at the next one. Increasing and decreasing intervals. So increasing or decreasing?
it's increasing.
Increasing. The whole time this is increasing. So negative infinity to positive infinity. Is there any decreasing?
No.
No. So you can just write none. Don't, on a test, don't leave that blank. Okay, I want you to write none. If you leave it blank, I am assuming that you don't know what the answer is.
The degree is 1.
Very good. The degree is 1. How many turning points does this have? None, so the degree would be 1. What's the sign of the leading coefficient? Positive. If on the right side of the graph it's going to positive infinity, then the leading coefficient is positive. If on the right side of the graph it's going negative, then the leading coefficient is negative. Okay, it's just a rule that you have to remember, or you've got to be able to put it back into the calculator and try to match it up with the graph. All right, let's look at the last one. Oh no, I got domain. Domain for this one.
Negative infinity to positive.
Range.
The same.
Okay, last one. Increasing, decreasing. Anybody think they can give that to me?
Decrease. Hey.
Okay, increasing negative infinity to negative 0.8, 0.5, anything like that's fine.
Can I say 1?
No, because you can only say the whole number if it's going right through the. Did you roll your eyes at me?
No.
It's right through the point, okay? If not, if it's between two numbers, then you've got to give me some decimal, okay? Right,
So
so,
it's next to 1, so it's 0.8.
yeah. Okay, union.
0.6 to
0.6 to 2.2. All right, then who else is decreasing?
Negative infinity.
Got it.
Negative infinity.
Okay,
Negative 0.9 to 0.6.
okay, so decreasing. Say that again.
Negative 0.9
Well, we're gonna stick with 0.8 because we use that, but yeah, negative 0.8.
to 0.6.
0.6. Good,
And then 2.2
good.
to infinity.
Very good. Sorry, I can't write on that side of the board. All right, how many turning points does this have? Very good.
What?
How many turning points does it have?
4.
How many turning?
Three.
Count the turning points. 3, which means the degree is 4.
Oh,
All right, let's look at this. So what the graph, the end behavior of this graph is going to where? Negative infinity. So what's the leading coefficient?
Negative.
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 Okay. Now remember, Brenna was saying earlier what the degree of this, okay, is even. So the end behavior is the same on this one. Okay, which they're both going down. They're both going to negative infinity, which means the leading coefficient has to be negative as well.
Domain is negative infinity.
Domain has
Negative.
negative infinity to positive infinity. And then the range,
Negative.
negative infinity to 5. And does that get a parenthesis or a bracket?
It's included, so it's a parenthesis.
Included, so it's a bracket. Questions on this? So this is kind of a recap from last time. Talking about end behavior, leading coefficient, degree, turning points. Questions? Sure. Okay, so for the range, I see it's going down and I'm moving up. And where's the highest value?
5.
5. Yes, Brenna. Anything else? Remember again, for the increasing and decreasing, you have to use the x values. You have to look where it's increasing and decreasing and list the interval in the x values. All right. Anything else? We ready to move on? Next. Turn page. Okay. Fundamental theorem of algebra says that the degree of a polynomial equals the number of complex roots. So the degree of a polynomial equals the number of complex roots. Okay, so that's kind of abstract, so let's talk about what that means. So first of all, what are roots? What's another word for roots?
Solution.
Good, solutions.
Zeros.
X-intercepts, roots, solutions, X-intercepts.
But aren't solutions?
Zeros.
Go ahead. Solutions can mean many things, right? Because if we're talking about systems of equation, solutions mean something a little different. What was our other one?
Zeros.
Zero.
Say that like
The solutions to x-intercepts? They're all the same thing.
All the same thing.
All the same thing.
Can anybody tell me what complex means?
Very
Complicated?
good.
Okay. And mathematically, if we're talking about numbers, what does complex mean? Give me an example of a complex number. 2,
I was 2.
1.
5.
How about 2i?
Oh yeah.
Yeah, right? Okay, complex is kind of the big umbrella that has everything in it, right? So this is saying that the degree equals, what's another word for degree?
Root.
What's the degree of this?
3.
3. Okay, so the degree is 3. So this function has 3 complex roots. It's the same. It has 3 solutions. It has 3 zeros.
Oh
Okay?
yeah, we just.
Alright, what about the next one? What's
Four.
the degree?
4.
So then how many complex roots does it have?
4.
4. Okay, do the next two. On your own. Okay, how about the next one?
5.
5.
2.
Oh, but 2's way back here.
So
1.
what?
Just because I question you doesn't mean that's wrong. I just want to make sure you understand. So, is it still 2? Yeah, okay, this just isn't in standard form. Remember that the degree is going to be the highest exponent. So 2 is the highest exponent. JJ, did I trick you? Did I trick you with that one? Alright, let's keep going. Alright, so what we're going to do today is you're going to have to actually find the roots or solutions to each of these functions. That means we're going to do it graphically, and then we're going to get to do some factoring. Which you love.
Which I hate.
No, don't say hate. Okay, so this first one right here gives you the example of the graph and then the standard form, and I've already factored it for you. Okay? So if it's already factored, how would I find the zeros if I didn't have the graph? What would I do with these two?
2 and 3.
Okay, well if I wanted to set up algebraically so that we can go slowly through the process, no eye rolling, what would I do?
You have to put it in the
You
box.
No.
you'd
Solve it.
How do I solve it?
Maybe X squared.
X
X plus 2 equals 0. X plus 3
X
equals
zero.
0. Stop trying to beat me to the chase.
Yeah. Now we can solve. You can't solve anything unless that has an equal sign, right? Alright, so then how would I solve this one?
Add minus 2. Negative
So x equals
negative 2
X equals negative 2. X
plus 3.
equals
X equals 3.
okay, so what are the zeros of this
Negative
function?
2 and 3.
Negative 2 and 3. Does that match up with what we saw on the graph?
Yeah.
Negative 2 and 3. Okay? Alright, do the next two, please. If you need help or you don't understand something I've said, please raise your hand. Okay, so let's make some connections here. So what we just talked about is the number of complex roots. How many solutions, just by looking at this, should you have? 3. There should be 3 answers.
Wait, which one are you talking about?
This one right here. There should be 3 answers. If the degree is 3, then you have 3 solutions. Okay? So if you have the picture, your solutions are here, here, and here. If you have factored in and you don't have the graph, then you set each of these equal to 0. So what are my zeros?
0.
Negative 0, negative 1, 3.
See how all this is connected? Like if you're not sure how to factor, then you can put it in the calculator. If you're not sure you've got the right answers, you can look and say, I know I need 3 answers. I only have 2. I've done something wrong. Okay? Alright, what about the next one? How many solutions should I have?
3.
4.
4. The highest number of degree, I should have 4 solutions. Alright? So on a graph, my solutions or roots are here, here, and here.
Ugh.
Or you set each of these equal to 0 and solve, because you won't always have a graph. So my solutions are
Negative 5.
0,
Negative 5.
negative 5,
6.
6,
3 halves.
and 3 halves. Okay? Yep. Nope, because I gave you the exact number. Oh, yeah, Grace, you're fine. Yeah, that's fine. But if it was like a decimal that kept repeating, then leave it as fractions. Bless you. Bless you, yeah. How do we feel about that? It's pretty easy, right?
Yeah. It's gonna get harder.
As long as you can factor, it doesn't get any harder. All right. go to the next page.
It's 10:50.
We're gonna make an announcement to call you. All right. So in this picture right here, is the degree odd or even?
Odd.
Even.
Odd.
It's even. Why is it even?
Because
like this.
Because it's 4, it has 4.
Because it's the same end behavior. It's going up, up, or down, down. That means it's even. Up, up, or down, down. What about this? Is this odd or even? Odd.
Even.
Bill's really getting it. So even, okay, odd. So going in the same direction, so it's even. What is this smallest possible degree?
3.
1.
How many turning points does it have?
3.
3. So what's the possible degree?
4.
4.
There you go. So how many solutions do you have?
You have 4.
4 solutions. Now, these solutions could be real or imaginary. Are these solutions real or imaginary?
Real.
They're real. So you have 4 real solutions.
Oh, you just
All
read
right.
how many
Oh
solutions?
no, look at the clock.
Nope. I want to do my dance again. All right, let's look at the next
Oh, look
one.
at the clock.
Okay, is it odd or even?
It's odd.
It's odd. The end behavior is going in 2 different directions, so it's odd.
Odd. Oh.
All right, how many turning points are there?
There's 4.
5.
How many turning points are there?
4.
4.
turning points.
So what's the degree?
5.
5.
Come on,
He's jumping ahead and wanting to answer the question. Okay, so how many solutions should I have?
5.
5 solutions. So how many real ones do I have?
2, 3.
Okay, here's where it does get tricky. Does anybody remember? Hold on. Does anybody remember what this is called when it bumps up against the axis like that? Did you say hump? This is called a double root. A double root, so this counts for 2. This right here is a double root, so it counts for 2. So you have 5. So how many real? do you have?
5.
You have 5 real. Nope, I match up. They should match. Yeah, we're going to talk about that a little more in just a second. But yes, you'll reckon when it bumps up against the graph, it's a double root. It counts for 2. You zoom in on your chart. All right, let's look at the next one.
Okay. It's definitely even. Definitely not odd.
Even.
Even, right? It's going. And behavior's going in the same direction, so it's even.
It's got 0.
Okay. How many turning points?
0.
1 turning point. So what's the degree?
2.
2 imaginary. Remember that it has to match, right? So I should have 2 solutions. None of them cross the x-axis, so I have 2 imaginary. How do we feel about that?
I don't know. I
Yep.
won't leave.
All right. Multiplicity. So the multiplicity is what we were just talking about, the double roots. Formally, we're going to say that the multiplicity is the number of times a given root is a solution. Okay, the number of times a given root is a solution. So we talked about this right here, okay? This is a root right from the side. This right here is a root. But how many solutions does this represent? Two. Okay? It's a root, but it represents two solutions. Okay? So this one here is two solutions. Okay, here's the other one. What about this one? This one's three solutions. Yeah, because that looks like the little S. It almost kind of like flattens out right there. Okay, so the difference is going to be. I know. The difference is going to be if it's like straight through or like at an angle through, that will be 1. But when it does that, it kind of looks like a cubic function. Okay, that's three solutions. So 2 solutions, 3 solutions. I know. So what would be the possible degree of this?
4. Because there's 3 terms.
Wouldn't it be 6?
Okay, first of all, would it be odd or even? Odd. How many solutions do we have? 5. So what's the possible degree? 5. Because the degree and the solutions are the same.
So if you find the solutions before you find the degree,
How about the one at the
tell you
bottom?
what the degree is, and then you can find out what the. So if it's 5.
What the possible degree is, because remember you could always have imaginary solutions too. Okay.
We're talking about that.
Okay.
On that graph. The bottom.
This one over here.
No. Same one we're talking about.
Uh-huh.
The bottom.
This is a Y, so we don't worry about that.
So we just add.
Solutions are just going to be on the X.
So, okay.
Okay. Will's mad at me, so let's go through a couple more examples. Miss Loza, did you want to add anything in?
I don't think so.
Okay. I think once we go through a couple more, it will start to make sense, I promise. Okay? Don't be mad at me. Alright, so label each multiplicity in the graph below. Okay? So label each multiplicity. So let's do the first one. We'll do the first 2 together. Alright, so where do you see a multiplicity? At what number? At -2. And is that a double or a triple root? It's a double.
So it would be 4.
No, it just depends. I just want you to get used to looking at it, okay? And then you're actually will just start telling me the solution. Alright, and where is the other one?
Next.
+2. And is that a double or a triple? That's also a double. So all I want you to do right now is just label, okay, the multiplicity and tell me if it's a double or a triple root. You want to do the next one together? One more together?
Maybe 4.
Okay, so where do you see a root at?
Right here on that.
Tell me the number. -2. And is that a single, a double, or a triple? It's a triple, yeah. Yeah, no. But it looks like it. It's just really close to the x-axis. It's just that you can't tell by this graph. But it's getting really close. It's not touching until it gets to -2. So this one's a triple. Alright, and then where's my other root? At what number? 2. And is that a double? Alright, you try the next 2. There are the answers. Alright, so graph the following and answer each of the questions. Alright, so let's go ahead and put this in the calculator first, and then we'll try to answer the question. So everybody get your calculator. Please be careful, make sure you arrow out. Odd is the opposite in behavior. Alright, everybody got this in their calculator? Good? Alright, so what's the degree of this? No. What's the degree? 3, right? Because it's the highest exponent, so I have a degree of 3. Which means how many complex roots are there? 3, because complex roots equals the degree. Alright, now, in order for us to look at the real, imaginary, double roots, triple roots, we've got to look at the graph. Right? So, how many real roots do you see here? 3. Which means, are there any imaginary? Nope. Are there any double roots? Nope. About triple? No.
I'll do 3.
Right. I only care about the turning point when it is turning right against the x-axis. Okay. The turning point any other place, as far as roots are concerned, we don't care about that. And then go ahead and sketch. So I'm going to put in my solutions here, and then I'm going to sketch my graph. Hopefully it'll look better than mine.
Wait, why did you put that at 1, isn't it?
Oh, yeah.
So it'd be negative 2, negative 3.
No, I meant the positive.
Yeah. Okay. We're just sketching. I'm not looking for perfection on the graph right now. Just sketch the graph. All right, turning points. How many turning points did we say? Turning points, 2. As x approaches positive infinity, f of x approaches positive infinity. As x approaches negative infinity, f of x approaches negative infinity. And what are our zeros? Think you can do the other two, or you want to do one more together? One more together? Do all of them together? That's so boring. That's just me like a girl from Charlie Brown.
Like the teacher.
That's the teacher.
Oh, is it the teacher?
Except you don't make them walk.
Alright, does anybody have questions on this one? Alright, let's do the next one. So let's go and put it in the calculator. That's where you want to start. Oh, the movie? No. Take us to see Star Wars.
Same. Minus 8 minutes. Minus 8 minutes.
Oh. I wish I had that kind of money. Shame. Graph. Okay. Okay, what are the zeros? So negative 3, but how many times are we going to write negative 3?
2 times.
Yeah. And then because I need to be able to account for all of those roots, okay? So there's 4. They're just repeated. That's why we call them double. All right, how many turning points? 3 turning points. Could you have, now Will said, well, I can't see how many turning points there are, okay? Which is valid. You could try to zoom out, but then it's going to get really, like, ugly, right? Okay, but what's the relationship between the degree and the turning points? Yeah, okay? So if you can take the calculator and use what's on the calculator and what you know from what we taught you, these questions are pretty easy, okay? Yep.
So wouldn't both behaviors be the same?
Yeah, same and positive. Because I'm writing from over here. Yeah, I think we should do the last one on our own. Okay, so what's the degree of this? 5. Please be careful. Notice I did not put this in standard form. It's the highest degree. Right? So how many complex roots should there be? 5. How many real? 3. 1. This one's a double, so 1, 2, 3 real. Which means that if I only see 3 real, what do the other 2 have to be? Imaginary, because the real plus the imaginary have to add up to the total complex. Okay, and how many double roots do I have? 1 double. So yes, there's a double. Is there a triple? No. What's the number of turning points? 2. Okay. Now, remember that the rule says that the number of turning points could possibly be 1 less than the degree. Okay? Doesn't have to have 4. Okay, the maximum number of turning points is 4. So this one, if we look at the graph, has 2. In behavior, good. Positive. Okay, that's good. Negative 1.4. And then 0.82. How do I find exactly if it's not going because this does not hit exactly at 1? How would I figure that out? Well, you could do the zeros or you could put into y equals. I'll do both ways. Y equals 0. And then I'm going to do the intersection. Okay, so I'm going to get close to where I think the intersection is. Apologies. And then let's do the other one.
It's 1 point. Well, I just rounded it up to
So if it's not, if you can't find it in the table or it's not exactly a whole number, then you've got to do either something in the calc menu. Either you can do the intersection as long as you have y equals 0, or you can do the 0, which is number 2. Just remember you got to do that left bound, right bound stuff. How do we feel about that? All right. All right, so for these, next page, you are going to have to factor them. So let's look at this first one. What's wrong with this? Right, it's not in y equals form. So what can I do to this to make it in y equals form? How do I do that?
equal it to 0.
Mm-hmm. What's the
x3, negative x3 minus.
Well, let's move the negative 25x. How about that? Because having a negative in front of the leading coefficient makes it a little awkward. So let's move this over. So x3 minus 25x equals 0. Is there any good gossip in there? Alright, now, once I have this, I know your gut intuition is just to plug it into the calculator. But I want to make sure, especially for those of you that are going on to pre-calc doesn't allow a calculator. Okay? So you've got to know how to do this algebraic. So if I have something like this, if I want to find the solution to this, okay, I'm going to factor it. So what's the first thing I should do to this? Yeah, not plus 25x. When I'm factoring, what should I always look for first? Starts with the G. Greatest common factor. Is there a greatest common factor?
X.
X. So I'm going to divide out x. So x, and then x squared minus 25 equals 0.
And it would be x plus 0 equals.
You could, but let's continue factoring because there was a question on the test that everybody got wrong. Okay? If I want a factor, so can I do anything left with that x? This x on the outside? No. Okay, what about this inside piece? X squared minus 25. What are the factors of x squared minus 25?
X. Well,
Plus x plus 5, x minus 5.
well, no. Wouldn't it be x minus 5 or x minus 5? Because isn't.
No, okay, so there's okay, alright. Slight difference. I know what you're thinking. Yep.
And then you could be x equals 0, and then x equals negative 5, and then x equals.
Exactly. Now I can set all of these equal to 0. So I have x equals 0, x plus 5 equals 0, x minus 5 equals 0. You could square root at this point. I just want to make sure that you guys know how to factor this because there's questions where it'll say just factor, not solve, and you need to be able to factor this.
Wait, but wouldn't the solution be 0, negative 5, or 5?
Yep. I just haven't got that far.
0.
Okay, so you're doing the same thing we were just doing, except you're doing it algebraically. There will be part of the test where you will have to do it algebraically. Okay? Okay, so f of x, this is just asking you to rewrite the function. So I have f of x equals x cubed minus 25x. That's our function. How many turning points, possible turning points does this have?
3. 4. Because.
It would be 2.
2, right? And before you put it into the calculator, what is the end behavior going to look like? As x, okay, so the degree is odd or even? Odd or even? Odd, so the end behavior is going to be, or opposite, right? And then as x approaches infinity, where is f of x going to go? Positive infinity because my leading coefficient is positive. And x, as x goes to negative infinity, f of x goes to. Alright, put it in the calculator. See if we did it right. So you're going to put this, don't put the factored form in, you're going to put the original function in.
So the x minus.
X cubed minus 25x. It's, the possible turning points is 1 less than the degree. Okay? It's a lot to remember, I know.
Holy.
X plus x. And then where do I go? Where do I go? Second graph, which takes me to the table. And what am I looking for in this column? Which number? No, I'm looking for -6, right? These two are the factors. This adds up to those two factors. So what are my two factors?
6 and
3 and -9. So don't forget your x that comes on the outside. And then so your two factors are x
X plus 3.
x plus 3, x minus 9. Now, how do I find the zeros, though?
X equals 0.
X equals 0. X plus 3 equals 0.
Negative 3. And 9. So it's 0, negative 3, 9.
So 0, -3, and 9. Yeah, so the original function is going to go here. So x cubed minus 6x squared minus 27x. What's the turning point? 2.
Wait, how is it 2?
1 less than the highest degree.
Oh.
Alright, and then the end behavior, okay, is this an odd or even function? Odd. Okay, so the end behavior is going to be opposite, and then the leading coefficient is positive, so to the right I'm going to positive, and to the left I'm going to. So go ahead and put that into the calculator. And sketch it, make sure that your answers look correct. But put in the calculator to check to make sure it makes sense. And then I want you to try one more. You can start it on your own. I'll probably walk you through it real quick because I want you to make sure that. Yeah, the X on the outside is taken out. That's fine. So do our factors and our in behavior match our graph? Alright, let's do the nice one. I feel like I'm losing you, but I want to go through this one, at least on the video. Alright, so let's look at this. What can I factor out of here? What's the greatest common factor?
X squared.
X squared. Okay, so what's left on the inside?
X squared.
X squared plus 4 equals 0. Okay, so then I have x squared equals 0. How do I solve this? Square root. So x equals 0. And then x squared plus 4. Can I factor that any further? No!
It'd be negative 2.
Nope.
No, it's just, yeah, you just
It's only the difference of perfect squares. This is the sum. There's no such thing as the sum of the. So I'm going to show you. So you're going to square root x squared plus 4 equals 0. You're going to be mad at me when we get done this. How do I solve this?
Oh, minus 4.
Minus 4, x squared equals negative 4,
And take a
square root.
And it would be x.
So x equals the square root of negative 4. How do you simplify that? This is all 2 units ago. This is review.
This is like
This is
2.
nothing new. There you go.
It becomes 2i.
Plus or minus 4i.
I thought it'd be 2i.
2i, you're right. Sorry.
Yeah, you see, that was
Plus or minus 2i.
Let me throw this out there also, because when you guys take the square root, don't forget to do this plus or minus part.
That's the only.
Well, and on tests and quizzes, a lot of y'all are just putting 2i. It's plus or minus 2i.
Wait, why would you put 2i instead of 4?
Because the square root of 4 is.
Oh.
Alright, throw that in the calculator real quick so you can see what that looks like compared to what our zeros, and we'll stop there. Plus 4x squared equals 0. How many complex solutions should you have?
Good morning, West
4.
Potomac. Please rise
How
for
many
the Pledge of
complex
Allegiance.
solutions do we have? 4.
I pledge allegiance.
How are you going to run the meeting?
No.
Alright, Miss Lewis,